Okay, so what is the schedule today? We're going to be covering section 3.3 on frequency distributions and histograms. Um, and we'll be ending a little bit early, around 20 after 1, to take a quiz. The quiz will cover chapters 1 and 2. You can use your textbook, you can use your notes, you just can't use each other, can't communicate with each other. So this is a very hot issue at Rowan right now, is people cheating, being online. So just know that the university does not take cheating very lightly. And there's no reason to cheat in this course because, again, open book, open notes. Um, I wouldn't understand at all why you would be cheating unless you're not doing any work, which is not a good idea. So please don't cheat. There's a good chance I could catch you, and then you can ruin your whole Rowan experience, which is not a great thing to do. So just I try to make this course not as stress-free as I possibly can. Um, but anyway, the quiz will be 20 minutes long, and again, it will have 5 problems. Problems meaning basically statements or sentences that have fill in the blanks. Now, the way I've set it up is that each blank is a drop-down box. So there'll be 4 possible answers in the drop-down box. You just select the one that's the correct one. Okay, and this way I will avoid spelling errors and things like that, which would be unfortunate if you spelled something wrong and got it wrong. So therefore, you just need to recognize the answer and choose that one for each of the blanks. And I believe there's like 16 blanks altogether that you need to do this with. All right, so that's the quiz. It should be fairly straightforward. And I would think if you've read the chapter, it should be probably the easiest quiz that you'll take this semester. Now, in addition, not today, but I'll be assigning some homework probably over the weekend. I'll give you a few days to complete the homework. The homework will be not like the quizzes where they'll have drop-down boxes, but there'll be answers that you'll enter into Canvas for the homework. So there'll be correct answers. And the way this will work is that as opposed to the quizzes where you only get one shot at the correct answer, with the homework, you'll get like 2 shots at it. So you'll know immediately whether you got the answer wrong in the homework, and then you'll have another try at it. So there'll be several homework assignments during the semester just to prepare you for the types of questions you'll see on quizzes and tests. But this quiz today, there's no math, there's nothing. It's all vocabulary and definitions. Should be a very easy one for you, I would think. All right, so let's get started with the PowerPoint. This is a very long PowerPoint presentation, but I'm going to skip around a little bit and then show you a demonstration using the TI-84 calculator of how to actually create this type of graph that's going to be talked about today, which is called a histogram. All right, so we'll pull up the PowerPoint. Okay. All right, so this is again chapter 3, and this will be section 3. All right, and this deals with what are called frequency distributions, which are basically tables, and the corresponding histograms, which are graphical displays of these tables. And this is for numeric data. Remember last time we talked about the difference between categorical data and quantitative data, or numeric data. These histograms are strictly numeric, and they'll look somewhat like bar charts. But bar charts, there will be categories that will be listed along the x-axis for a bar chart. For histograms, it's a numeric quantity that will be along the x-axis. All right. Now, frequency distributions and histograms for discrete numerical data. Remember, discrete meaning particular values that can be you can put a dot on a number line for each of those values. Many times it's numerical values that are counts, the number of people, number of things that we're counting. So So discrete numerical data, we can create these so-called frequency distributions and histograms. Now, the word frequency means count. We're counting the number of instances in our data set that have a particular number, right? So we're looking for repetitions of the same number, and we're just counting them. That's basically what we're doing, all right? It's nothing more than that. Anyway, we're going to show you the case of where we have discrete numerical data. Basically, where the numbers are basically typically counts of things. So we're counting the number of counts, which is kind of strange to say it that way. And then I'll show you the case where we do frequency distributions and histograms for continuous data, which is more common. All right. So, the word frequency is basically a count, and a relative frequency is a percentage. So if we're counting the number of values of, let's say in your data set, you have a number of numbers, and let's say some of them are the number 2. All right. So maybe the number 2 shows up in your data set 5 times. So the frequency would be 5. All right. So the number 2 shows up 5 times. The frequency is 5. The relative frequency is the percentage of all the numbers in your data set that are the number 2. All right. So if there's 20 numbers in your data set and 2 shows up 5 times, 5 divided by 20 is what is that? 0.2 or 0.4? 0.4, right? 0.4. Is that right? Am I right about that? Anybody can correct me on that? 5 divided by 20? It's 4. That's the same thing as 1 divided by 4. So that's 0.25. All right. Just want to make sure you're awake, but you're not yet. So that's what a relative frequency is. It's a percentage. It's a decimal. Typically, it's expressed as a decimal, but you can also express it as a percentage. So 5 divided by 20 is 1 out of 4, and that's 0.25 or 25%. All right. Okay. Let's look at an example of this. Here's a data set. And when we say data set, we're just saying there's a variable, one variable, and there's a bunch of values or observations for that variable. But here it's the number of partners on one mating flight. I guess the mating flight, I guess we're talking about birds, maybe, I don't know. Or bees, I'm sorry. Promiscuous queen bees, there we go. So this is in your textbook. Maybe if you've read your textbook in this chapter, you'll know about this scenario here. So how many data points do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 30, right? There's 30 different bees that were looked at, and they were counting the number of mating partners for that particular bee. So there's one bee that had only 1, and there's another one that had 12 partners. All right, so it goes from the values here go from 1 all the way up to 12. Now, if we were going to do a dot plot here, we would, have a number line, and we would have numbers that go from 1 to 12, and then we just put a dot above each time that particular number shows up in the data set. So the number 1 only shows up once, so we'd have 1 dot there. The number 2 looks like it shows up only once. The number 3 shows up how many times? It looks like once. Number 4 shows up once here, and there's another one down here, and another one down here. So it looks like 3 4s show up. So if a dot plot would have 3 dots stacked on one top of each other, the number 4, and so forth. So you can use a dot plot to actually plot these values here, or you can do a histogram, which is what you're going to learn today. So one way of expressing these values here is through a what's called a frequency distribution table. Okay, so we list all the possible values in your data set, 1 up to 12. You list them in order, and then the frequencies are just the number of times the number shows up in the data set. And remember, I said there was only 1 1, there was only 1 2, there's only 1 3, but there were 3 4s. Similarly, you would see 5 6s, 7 7s, 4 8s, and so forth, all right? So those are the frequencies. Now, how do you come up with the relative frequencies? You just take your frequency and divide by what? 30, the number of values in your data set. There are 30 Bs that we were looking at, so 30. So 1 divided by 30 is 0.033. 3 divided by 30 is 0.10, just like that, all right? Now notice that when we add up the relative frequencies, it should come out to 1, but in this case it says 0.999 because of rounding, all right? It's just a rounding issue here. I guess if we went out to 4 decimal places, we would probably have, it would add up to 1. But it doesn't really matter. Rounding is rounding, and sometimes we have it's a little bit slightly different than the total, but the relative frequency should always add up to 1. Okay, so we have the smallest value is 1, the largest value is 12. We have our relative frequencies. All right, and now, if we wanted to say something about if we wanted to add relative frequency together, for example, if we wanted to know what is the relative frequency for the values 10, 11, and 12, we would simply add up their relative frequencies. So if the relative frequency for number 10 is 0.067, for number 11, it's 0.033, for number 12, it's 0.033, we would simply add up those relative frequencies, and we would say that 13.3% of the queen bees had 10 or more partners. Now, why do we say 10 or more? Because there weren't any bees that had more than 12, right? So 10 and 11 and 12 basically would be 10 or more, because there's no bees that had more than 12 partners. All right, so we can ask questions like that, right? When we can add up relative frequencies to answer those questions. I hope all of this makes sort of common sense to you. It's probably not something new. All right, we could also group the number of partners. We can create what are called classes. All right, classes. So we could have 4 classes here. In other words, we could say, all right, instead of just counting the number of partners for counting the number of partners for one of the bees and saying, all right, let's count the number that had 1 partner, 2 partners, 3 partners. We could group them together. We could say, all right, how many bees had between 1 and 3 partners? All right, and we would say, all right, we would look for those bees that had 1 partner, those bees that had 2 partners, those bees that had 3 partners, and we would find there were 3 of them. Same thing with 4 to 6 partners. So we can group our quantitative variable, which is the number of partners. We can group them into these so-called categories. First one's category 1, 1 to 3 partners. Category 2 is 4 to 6 partners, and so forth. And we're just combining the frequencies for each of those, each of the groups. And then we can have relative frequencies for those categories. So for category 1, 0.10 or 10%. Category 2 is 33.3%. With category 3, 43.3. Category 4, 13.3. If you added all these up, again, it comes out to 0.999, but it's again rounding, and a rounding issue here, and it should add up to 1. All right, so we could, for discrete numerical data, we could actually just have account for each value in the data set, or we can group them, and which might make more sense. All right, so that's possibility there. Now, the graph that we use to display a frequency distribution table is called a histogram. All right, this is for numerical data. That's important because when we created a graph for categorical data and we were counting the number of values for each of the categories, that was called a bar chart. But when our variable is a quantitative or numerical variable, then we use what's called a histogram. All right, and we can create either what's called a frequency histogram or a relative frequency histogram. So we'll see what that means in a second. Okay, and what they're showing you in the slides here and also in the book is the long way. It's the way before we had calculators, before we had computers, of creating one of these histograms. So they show you how to do it manually. All right, they go through the steps. It should make some sense how to do it. You draw a horizontal scale. You mark the possible values of the variable on the horizontal scale. All right. Along the vertical scale, it's going to be either a frequency, the number of counts for each of those values, or a relative frequency, which is the percentage counts. All right. And just typically you draw a rectangle centered around that value. All right. So we'd have around the number 1, we'd have a rectangle, and each of the rectangles would be the same width. That's typically what you do. And then the height of each rectangle is determined by the frequency. So the height of the rectangle is the frequency or the relative frequency. Okay. Now, what would be the point of drawing one of these histograms? Well, it gives you some information about the distribution of the values in your data set, which would not necessarily be obvious by just looking at all the numbers in your data set. Number 1, it'll give you an idea of where the center of your data set is, where most of the numbers are centered. Also, what an important topic in statistics, variability, how wide apart are the values in the data set. The general shape, whether it's symmetric or skewed, we'll talk about that later. And also where if there are more than one peak in the data set. In other words, if it seems like the frequencies are going up and then start going down again, that might be one peak, or we could have 2 peaks. Sometimes we have values that are unusually large, unusually small, or there's some values where there's no counts. These are the gaps and outliers. And this is what the histograms look like. Now for the Queen Bee data, if we simply, we have our 12 values here, we simply draw a rectangle surrounding each of the values, and we make sure that they are adjacent to each other, they're touching each other. All right, so we would have 12 of these rectangles. The height is going, in this histogram on the left here, the height is going to be the frequency, the number of values in your data set for each of these number of partners. So there's only one B that had 1 partner, only one had 2, only one that had 3, but you can see here that were 3 that had 4 partners. If you go out here to 7 partners, you can see there were 7 Bs that had 7 partners. If you decide, instead of having frequencies along your y-axis, if you have your relative frequencies, the histogram will look exactly the same, except the heights now are going to be relative frequencies as opposed to frequencies. Okay, but it will look exactly the same. There won't be any change to the way the chart looks or the graph looks. Okay. All right. If you were going to use grouping, if you were going to create categories, in other words, from 1 to 3, from 4 to 6, like that, you could create a histogram that looks like this, where we have only 4 categories as opposed to 12 individual values. And therefore, this would be another way of displaying your histogram. All right. Any questions about that? All right. Now, more likely, what you're going to see are frequency distribution tables and histograms for continuous numeric data. All right, continuous meaning these are things that these are values that we're measuring as opposed to counting. So this will be something that we'll be going over with you today. See how we're doing time. All right. I'm just as a note, if I don't get to finish this section, we'll finish it next time on next Monday. All right, so don't worry about it. Probably won't finish it all. There's a lot of slides here, but I'll get to most of it before the end, before we have a quiz. Now, again, continuous data could be something like weight, carry-on luggage weight. All right, now weight is continuous. It's a continuous number. It could be any value between certain values, right? When we say 30 pounds, it could be 30.3 pounds. It could be 30.333 pounds, like that. Depending, and the limitation is basically the scale that we're using to measure measure weight. But weight could be any value in between two values in an interval, and therefore it's continuous. All right. Now, because it's continuous, we're always going to use class intervals for this type of frequency distribution table and histograms. We're not going to use individual values because, again, these are continuous numbers that we're talking about. Okay, so class intervals will be used in all these cases. So we'll look at an example here. So histograms work well. If you remember with the dot plots, we talked about dot plots as a way of displaying numerical data when the data set is relatively small, just a few, maybe up to 50 or 100 at most values in your data set. But with histograms, we can have hundreds, thousands, millions of values, and we can display it with a histogram. So that's the value of having a histogram. So in the same way as we did for discrete numerical data, if you were going to do this manually, you would mark the boundaries of the class intervals on the horizontal axis. And this is something I will show you how to do in a minute with your calculator. So we're going to do an actual example of this with your calculator. So we're going to mark the boundaries of the class intervals on the horizontal axis. We're going to mark the frequencies or relative frequencies on the vertical axis. We're going to draw a rectangle for each interval directly above the corresponding interval. We want to make sure the edges of the rectangles are touching each other for each of the intervals. And the height of each rectangle is either the frequency or the relative frequency we talked about before. Once again, the same types of things that we can talk about when we look at our histogram, the same type of things about the center, variability, the shape, number of peaks and outliers, that sort of thing. Right? Again, when we get near an actual test, which will be coming up fairly soon, then I'll show you an example of how to interpret a histogram. All right, this is an example here. Sleep deficit and school start time. It's the influence of school time on sleep patterns of children. They studied students in Brazil that offered both morning school start time and afternoon school start time. And the variable of interest was sleep deficit. So it was basically defined as the difference in sleep duration on weekends and the sleep duration on nights with school. All right, how much less did you sleep during the week when you went to school as opposed during the weekend? So that's what the measurement was, this measure of sleep deficit. All right, and so sleep deficits could be measured as negative values, could be measured as positive values, because let's see how they define it here. For example, if a student typically sleeps 9 hours a night on weekends and 7 hours on weeknights, they would have a sleep deficit of +2. That means a -3 means they actually sleep more on weeknights than they do on weekends. Okay, so that's how they define sleep deficit. All right, so they're counting. Well, in this case, they don't show the actual frequencies because there was probably lots of them, hundreds maybe. But in this case, they showed the categories. There was 1, 2, 3, 4, 5, 6, 7 categories. And basically, they were counting the number of children with sleep deficits between -6 to -4. Now, notice here they put less than -4. That means -6 up to, but not including -4. If you actually had -4 as your sleep deficit as a child, it would show up in category 2, which runs from -4 up to, but not including -2, and so forth. So this is how you came up with your categories. You had your counts, and then for each of the two groups, the morning start and the afternoon start kids, for each of these two groups, they calculated the relative frequencies for each one of these categories, right? If you add up the relative frequencies, it should come out to about 1, okay? Same thing. So they have two groups, and in this case, you would create two histograms. And this would be called a relative frequency histogram because what's running along the y-axis are the relative frequencies. Along the x-axis, we have our groups. Notice that the first group goes from -6 to -4, then from -4 to -2, -2 to 0. Same thing, the same categories for each group, and then we have our relative frequencies shown for each of these groups. Okay, and then you can compare. You can compare these two groups. You can make some sort of interpretations. All right, now the interpretations I'm going to leave off for now. We could talk more about that next Monday, at the beginning of the period. But for now, I just want to show you how these things are created, all right, and what they mean. All right, and again, they are interpreting the histograms in this slide here. They say both histograms have a single peak. Majority of students in both groups have positive values for sleep deficit and so forth. But don't worry about the interpretation yet. I think it's enough right now that you learn what a histogram is and how to actually create one. All right. Now, I'm going to hold off on this particular topic right now, classes, intervals of unequal widths. I'm going to hold off on that totally because this is a specialized topic and I'll show it to you, but it's not as important as what I just showed you. All right. So it's something that you should know, but it's not critical that you know it. And then there will be some other things towards the end that I'll show you again on Monday. All right, so we're going to stop right here. That means we've covered the first 31 slides in this section here. And what I'm going to do now is show you an example of how to create a histogram with your calculator. All right, and this is going to be their first exercise using your calculator. Hopefully you have it with you today because I did ask you to bring it along. And let me see, there's somebody in the chat here. 4, I don't know what that means. All right. Now be careful, folks. I have to give you a warning. Last semester, there was a class that attempted to communicate with each other by sharing phone numbers, email address, whatever they did. I forget what it was. And I put an end to it. So don't do that. Do not share that sort of thing. I can catch it. And again, the university wants all professors to report cheating because everything's being done online now. So please don't do this. If that's what this message means, I don't know what it means, but please don't do it. All right? Because I will be able to tell. I'll be able to tell. And then if there's lots of you doing it, it's just going to be a bad situation. So don't cheat. All right. Everything's open book, and there's no reason that you should be cheating. All right. So what I'm going to do now is share with you the calculator, and please have your TI 8384 calculator available so you can follow along. Now, if you want to view this the recording later and follow along slowly, that's fine. But it doesn't. It doesn't matter. It doesn't matter. So what I'm going to do, actually, I think what I'm going to do before we share the calculator is I need to find this problem. Now, if you have your textbook with you, this is in your textbook on page 113. It's problem 3.25. All right. This is going to be an example of a couple things. We're going to learn how to enter data into our calculator. We're going to learn how to find things with our calculator, just a couple things today, and also how to create a histogram with your calculator. So I think I can do all of this in 15 minutes. But what I would like to do first is, and just give me a second here, I want to open up Cengage and see if I can get the ebook open and then show you that problem on the screen in case you don't have your textbook with you. Just give me a second here, see if I can get it open. Sometimes Cengage, there's some difficulty getting the textbook opened up, and sometimes it's very, very slow. So see if it'll work today. All right. So far, so good. So you don't see it yet because I'm not sharing the screen with you yet, but hopefully this will open up. Tried earlier and couldn't get it open. All right, here we go. It's open now. We got to get to the textbook. Where are you? Give me a second here. There we go. All right. So again, it'll be another half a minute or so. Should be able to have it open. Okay. So we are in section 3.3. Let's see if I can get directly there. Here are the exercises. Great. And I have it open. So let me share this with you. And all right, so you should be able to see this now for those of you who don't have the textbook with you, but please pay attention because what I'm going to ask you to do is I'm going to ask you to enter this data in a minute directly into your calculator, but I'm going to show you how to do it first. So I'm going to stop sharing, but this is the problem I'm referring to, 3.25. It has to do with wind speed. All right, wind speed. Let me just move something out of the way. In Hong Kong in meters per second for each year in a 45-year period. So these are 45 numbers that you're going to be entering into your calculator in a second. All right. So what I'm going to do now is I'm going to unshare this and go back to the calculator. And I'll show you the steps first, and then I'll go back to that screen, and then you'll enter the data to give you a second to do that. Hold on a second here. Now, all of you probably, if you've had this calculator before, you've used it for algebra probably, for some other subjects, maybe pre-calculus, but you've never used it for statistics, most likely. But you're not familiar with what's called the stat key. There's going to be a couple keys here that you'll be using for the very first time. And right here on the third column of your calculator, and this is true in your 83 and 84 calculator, there's a button saying stat. So you should click that button. And you'll see a screen that looks like this. Now, edit is where you're going to be entering data. So if you've never used this before, you're not going to have any data at all in your calculator. So what you're going to do is you're going to hit your enter key. So it's data, it's edit, and then your selection is edit again. Hit enter. Now, there are what are called lists in your calculator. There's L1, L2, L3, L4, L5. In your calculator, by the way, if you ever want to enter a list, the way to do it is you hit the second button, your blue button on your calculator, and then you look for that number. Notice right above each of the numbers in your calculator, there's blue where it says L1 above the number 1, L2 above the number 2, and so forth. So if you ever need to type the list L1 or L2 or L3, you simply hit your blue button and then go down to that number. And that will actually print that list on your screen. And there will be instances where you'll need to do that. But since this is you've never used this before, you should have everything clear here, including L1, which is list number 1. I have numbers in here, but I previously, before this class, entered these 45 numbers into this list. So what I want you to do now that the highlight, the black highlight here should be on the very first line under L1. And what you're going to do is you're going to enter each of these 45 numbers one at a time in this list. Now, the list is going to represent a variable. In this case, the variable is what? It's going to be wind speed, annual maximum wind speed, all right? 45 days or 45 years. So you're going to enter these numbers one at a time. It doesn't matter the order. Just make sure you take your time and get them all in. I'll give you like 2 minutes to do that. And after you've entered one number, you hit your enter key on your calculator that's down here, and that takes you to the next one. Or you can simply use your arrow key and point to the next one. So go ahead and enter your 45 numbers. I'll give you 2 minutes to do that. And then when you're done, again, in 2 minutes, I'll just get started again. And don't worry if you didn't manage to get all of them in. Follow along anyway, follow the steps. You'll be able to go back and look at the recording once again. So go ahead and do that, enter all 45 numbers, and then I'm going to show you a couple things today of how to use this calculator. And again, since you have this recording, you can go back and learn how to use it. So go ahead and do that. I have right now about 9 minutes after 1. So we'll talk again in 11 minutes after 1. And then for about 5, 6, 7 minutes, I'll show you some features here. And then I'll show you how to create a histogram using your calculator. So go ahead and do that. And also, I'm sorry, for those of you who don't have the textbook, let's go back to the textbook, the ebook. Sorry. And let me show you those numbers again. So give me a second here. There we go. So there they are. And maybe I'll make this a little bigger so you can see the numbers. All right, there we go. All right, it's 11 minutes after. Again, keep entering if you haven't quite got them all in. What I'm going to do now is go back to the calculator.